Assalamualaikum warahmatullahi wabarakatuh. We are from the group of Phoenix. We will start our presentation with the title of Home Heating. Here is our presentation outline. Let us proceed with the introduction part. First, the background of the study. The definition of the home heating system is a combination of the components required to provide a form of indoor air treatment and resulting the temperature to increase. The purpose of the home heating system is to create warm and comfortable conditions for the human to live in. According to the Osdimer in 2018, home heating system contribute 1/3 of the country energy consumptions. For the objective of the study, first, to investigate the changes of the temperature in the home heating system, which consists of insulated main living area with uninsulated attic and the basement. Second, to determine a particular solution to the non-homogeneous system of ODE using the method of variation of the parameter. Third, to use the Python language to solve the system of ODE. For the scope of the study, first, we study the application of the Newton's cooling law in the home heating system. Second, the study of the changes of the temperature is restricted to the area of the home heating system, which are the attic, basement, and the main living area.
I will continue with the mathematical formulation. So this is the system of first-order differential equations that will represent the temperature over time inside house. So xt, yt, and zt are the temperature of the basement, main floor, and the attic at time t. T is time in hours, and K0 and K4 are the cooling constants on the boundary spaces between the house parts as stated here. And this is the provided temperature by the heater per unit time. And these are the initial conditions, and these are the values of the parameters that we consider in this further. Assume that is winter and the outside and basement temperature as stated here, and we'll apply the Newton's cooling law on the boundaries between the house parts and their surrounding. So to get the rate of temperature change in the basement, we need the cooling constants on these two boundaries multiplied by the temperature difference. And the same goes for the main floor and the attic, except that the main floor have additional amount of heat provided by the heater. And after we put all the differential equations together, we get the complete system equation as shown in the previous slide.
I will continue for results and discussion. Manual solution. This is a non-homogeneous system with initial condition, so we have to find the corresponding homogeneous system. For this case, we have to find the eigenvalue and the corresponding eigenvector. After we got the fundamental matrix, and we have using Gaussian elimination method to find the inverse. And then we obtain the solution to the IBP problem. And so we have to continue to solve for the particular solution by using the method of variation parameter. Then lastly, we have to add the homogeneous system and a particular solution to get the general solution. For computer-aided solution, we have to import the function that we will use and then declare all the variables that we will use. And first, we have to print the non-homogeneous system before and after the substitution and find the eigenvalue, eigenvector for the homogeneous system. And we have to find the general solution to the homogeneous system and the general solution to the non-homogeneous system that satisfy the initial condition. Then we have to plot the graph temperature versus time. By comparing from the both method, we've got the same answer for the general solution. The graph, we can see a significantly increase from 0 to 3 hours and gradually increase from 3 to 5 hours and plateauing from 5 to 10 hours for all the three areas. And we can see that temperature in the main floor is the highest, and because having an insulated area helps to reduce the thermal mass and respond quickly to the heating system.
I will be explaining on the conclusion and recommendation of this model. In conclusion, a common heating system in a home with insulated main floor and uninsulated basement and attics are measured. Okay, using Newton's cooling law, the heating system is modeled by a system of linear ODE. The conditions on the cooling coefficients will be under consideration. Okay, so this will actually to give a general techniques for any home heating systems. Okay, so that it can be applied to any typical systems. Okay, and then for the recommendation, the type of insulation used, okay, for instance, wall and roof insulation can actually moderate indoor temperature. Okay, the next one is the types of the building. Proper use of the building envelope thermal insulation will actually reduce the annual energy requirements. Okay, and last but not least, autogenous self-healing capability. Okay, this will actually allow the microcracks to seal and potentially heal.